Hello everyone, this is Shreenandan, and in today's video I have explained one of my project which is in SCTIMST Trivandrum. The main aim of the project is to display SpO2 and the raw PPG signal, uh, and once the data is being shown I can record it, and once the recording has been done I can visualize it again. So this is the basic app, what it does. I have used MIT App Inventor to build the entire app. MIT App Inventor is basically a web-based drag and drop tool. I have explained every code blocks used in this app, and I have added a demo video to it. Once you have seen the demo video, we will go to the code blocks or the coding blocks which has been used to develop the entire app. I hope you will like the video. Thank you.
Hello everyone, this is Shreenandan and welcome back to my channel. This is a app called Chitra PMS, developed under Dr. Chitra at Sri Chitra Institute of Medical Science and Technology, Trivandrum. This is an internship project, so I would like to demonstrate what are the features of the app and how I built the app. So whenever you click the app, it will land you upon this landing page, and then it will redirect you to a function page where you are allowed to choose between two options. This app can visualize the PPG live or can show or visualize a recorded data which has been recorded using the live data feature. So there are two features. We'll start with the live data feature. So here is the live data feature. Here is the basic UI of the app. Here you are please select your device, says you can select your device, select your Bluetooth device. In my case it's ESP32 which is sending the data. Here you will see the SpO2 value which is being calculated using the value sent by the device. Here is the area to show the plot, and under that you have a patient's name entry region and a record button. This app can record continuously up to 20 seconds and then can save it according to the name given over here with the timestamp to it. Okay, so once you connect, so how to connect? Once you click on the please select device here, it will redirect you to this page where you can select your device name. Here, as you can see, there is a Chitra PMS. Once you connect into it, it will start displaying the SpO2 values. So, for example, this is one of the instances where SpO2 was being sold. So here the plots will be like this. To be careful about this thing, we are using simulated data. So once the simulated data is being sent over Bluetooth, it captures it and first of all shows the displays the plot and then calculates the SpO2 value. As of now, the SpO2 value is about 88%, or sorry, 85%. So it's all green. You can see the label showing the SpO2 value is also green, and the perimeter of the screen is also green. Once the SpO2 value falls below a certain label, it shows it as a red indication. Over there, the SpO2 value label becomes red and the perimeter also becomes red. So now, once the live view is being displayed, you can have recording section. Once, as you saw in here, record data. Once it is played, you will find this thing going on, a countdown going on, up to which you up to the time up to which you will record it. That will be shown over here. And once the recording time is done, it will show a record success, where it will be showing the name of the file saved and the timestamp at what it is saved. Okay, these are the basic UI structures. Then we'll go back to a recorded thing. Once we go to save data, we can visualize those things like this. So this is the basic UI. Please select your CSV file. This will redirect you to this page where you are allowed to select 2 to 3. Sorry, at a time there will be displayed all the CSV values. Sorry, all the CSV files which have been recording using the recording app will be displayed over here. And you have to select one CSV file to open it up. Once the CSV file has been selected, you can load the file and it will visualize this thing, visualize the data in the CSV file. Otherwise, you can share it with your friends also, or you can share it over different media. Share the file. When you click that, you will be prompted to another page where you have different options to share. So this is the basic structure of my app. I'll be adding an entire screen recording of the app. Now we'll go to the code blocks which has been used here. I've used MIT App Inventor to build this app, which is a drag and drag and drop tool, which is web based. We can use it very easily. So we'll start with the first feature, like selecting the device. So there is a list speaker. This is the list speaker, which actually before selecting it, it basically lists out all the paired Bluetooth devices. Now once I select one of the devices, it will connect to it. So that's why it's written over before picking the devices. And then the speaker will list out all the paired devices. Then when I pick it, or when I select one of the devices, it will call the Bluetooth client using that same address which has been picked. Then it will connect to that device, connect to the address. Then what it does is basically this changes the UI of the thing. Like if the device is properly connected, like Chitra PMS connected, and it will turn green, as you can see here. And if it's not connected properly, then it will turn red. This is just an UI and to connect into the Bluetooth module. Then we have the main feature which plots everything. Here we are initializing some of the values which will be holding the raw data coming out of the device. Initializing some global values, variables. As I told, our heart rate goes from around 50 to maximum to 120 or 130, and in rare case it goes beyond that also. But we are restricting ourselves to 50 hertz or 50 beats per second to 150 beats per second. So according to that, we found out the frequency, and according to the frequency sampling has been taken to be 4 to 5 times the frequency of the signal. So for us, the frequency of the signal will lie in from 0.25 hertz to around 3.3 hertz, and we safely took the value or the sampling value to be 20 hertz per second. So we'll be having 20 samples per second, which that means every sample will be given every 50 milliseconds, right? So the gap between two samples will be 50 milliseconds. So we have initiated a timer which will fire every 50 milliseconds. This is the clock 1 timer. Once it is fired, it will first check if the Bluetooth is connected and if there is any available bytes for capturing. So it checks if there is any byte. That's why it's the available byte should be more than 0. That's why it's comparing and looking at if the byte value is more than 0. Then comes the capturing of the raw value. First, the global raw data captures the 4-byte integer, unsigned integer from the Bluetooth and stores it in global raw data. Once this is done, we'll add those raw data into a list where the list name is data list, where it has been initiated with an empty list. Okay. Then it will go once we record those, once we capture those raw data, we'll go for displaying the raw data. Here we have a component called line chart data. As I showed, this was the component which we'll be using this. Line chart data has two parameters, x and y. So we are incrementing the x-axis by each and every 50 milliseconds. That's why it's an incremental function. Every time the loop starts or the clock ticks, we have the x value incremented, and that is also added to the as an entry to the graph. Okay. Now we cannot have infinite number of timestamps or infinite number of data points which will be visible in the graph. So what we do is for every 5 seconds we show that, and then we move the window. Once the window is moved, it will show the past 5 seconds of data. For example, I'm looking at this plot at this particular instant. It will show me particular instant and 5 seconds back, up to the 5 seconds back. Okay, it is called the windowing thing, and we have implemented using, like as I told, how it is 5 seconds every 50 milliseconds. It is updating, or the value is being updated. So for 1 second we have 20 data, and we are allowing only 100 data. So 100 divided by 20 would be 5. So that's how the 5 second thing gets, or the 5 second window period comes to us. So we're checking that if the value or the data entered into the list is more than 100, the number of data in the list is more than 100, we will pop up the first, like it acts like a FIFO first in first out there. Whichever element was 100 from this instant, 100 from this instant, it will be removed, and that also will be removed from the graph. This is how the thing is implemented. So once we remove from the back, we have new data coming from the right. Okay, so for example, it's an array of 100 elements. We'll be popping element from the front, or the head of the array, and from the back of the array we'll be adding. So it will be always 100 elements in the array, and it will update, and it will flow like a smooth graph. Okay, that is the thing which is being implemented over here. And exactly, yeah, that's all in the graph section. We'll move on to the SpO2 calculation section. Here, this thing is SpO2 calculation section. As I told, this is a dummy thing. We are just averaging it out, averaging it the PPG value and showing it. So it's need not to be the accurate value, but the formula can be implemented over here. So I'm taking a list of those values and averaging it out. This is the function to average it out, and we are giving a 2500. Like, why it is that? Because we have said as it is a simulated data, it has a mean value, and if it crosses the mean value, we'll be having good amount of saturation, of 85% of saturation. If it goes below that, it will be around less saturation. So that logic has been implemented over here after calculating the SpO2. Like, this is not the actual calculation of SpO2, but a dummy thing. We can implement any kind of calculation over here, and it will calculate every second. So SpO2 value is updated every second. You can see that, and every time it is calculated, it is compared to a threshold value. That is, here I have mentioned 85%, but it can be anything. After that, if it is below 85%, then there is an alarm set over here. As I told, there are red color thing here. as it is here. The red color thing would be there. It will be SpO2 below 85% would be shown in red color, and there would be some auditory alarms and vibration alarms, so that the patient or the caretaker would be alarmed about the hypoxia condition. Okay, this thing takes care of that, and if it is in normal level, then it will be shown in the green color. So this thing is still ambiguity, and this has to be cleared out once we go into the further stage of the development or the hardware development, where we have the real sensors to capture this. Then we'll move on to our next section, which is the data recording section. Okay, as I shown here, this is the section which will be doing the recording for 20 seconds and will show the countdown prompt that the data has successfully saved. Okay, that's what we are implementing over here. We have a record button, right? This button, once it is clicked, that triggers a lot of timer. The total duration timer is the clock 3, and the sampling rate has been set by the clock 4. And once the button is clicked, we don't want it to be clicked again. So we don't want the debouncing of the button. So we have disabled that thing, and we have set another clock, which is clock 5, which counts up to 20 seconds, and it counts it fires every 1 second and updates the time duration of the countdown. We'll see in the last section. The clock 4 timer, incrementing the index. Okay, so this, what it does is basically captures the so for 20 seconds we have 400 data points. Like each second has 20 data points and 20 second data actually, so it's around 400 data sets. So each timestamp, each data has to be demarcated or indexed. So this thing, global data count, does that thing. It increments every time the clock ticks, and this is then added to our data frame or the array we are storing. Two-dimensional array. It stores in the first index, it stores the index of the count, or the count of the data points, and the other is the raw data point. And every time 2 points are selected, then it is going to the next line. So this is how the functionality occurs. Basically, this is a text, because in MIT App Inventor we are allowed to only save texts, which is then converted into CSV. Okay, so we have to arrange the text in a particular way. Like we'll have first element to be our index, second element to be our data, and then it has to go to the next line. And then again there would be index, then there would be data, index, data, and that way it will store. So that's why we have all those things straight over here. It is incrementing the count or the index, then it is recording the global global raw data over here. This is the main thing which is stored. As I told, it's a text. So every new text will be added to the previous text. So it is which is adding the previous text, and this is the new updated text. Global record count, which will be the incremented value of the index, and then separated by a comma. Then comes the raw data. Raw data is the thing which is captured by our signal. Sorry, the Bluetooth client over here. This thing is capturing the raw data. That is again used in the recording of the CSV file. So here the raw data comes, and we have a \n, which indicates a new line. Okay. That's all for the data recording system. Then we have the countdown system. This counter fires every 1 second and decrements the counter. Like it was 20 seconds, then it will be 19 seconds, 18 seconds, 17 seconds, then that on. And once it hits 0, it will show that recording has been completed. And near the value would be updated, the UI would be updated. Okay, this is the countdown, and then we'll move on to the saving the recording. Once the data has been put into the text format for the 20 seconds, we'll save it to a CSV file. Then reset all those parameters like the timer, the button, on all those things, and clear out some variables. So initially we'll initialize a file name called test. If there is no file name, it will defaultly give out a name called test. So when the clock or the 20-second timer goes down, timer is hit, timer gets over, then there are 3 clocks which has been resetted, resetted to 0. Clock 4 was basically the total duration, or sampling rate, that will be reset to 0. It will be stopped from firing. Clock 5, which is the countdown, it will be also stopped from firing, and clock 3 itself, the 20-second timer itself, has to be disabled. So these all disabling things goes here, because we don't want every time it will fire automatically. We want our button to trigger all these things, which has been mentioned over here. So then it checks if there is any name given to the recording file. If it is there, then it will take that name. Otherwise, it will take the default name which is mentioned over here. Then we are basically arranging the name into a format. Like we are adding either the default name or the user given name, adding a data frame, date time value to it. It will be like time, and then the date of the month, and date of the year, and then at the end of the day, that is the format of the file. It is .csv. This is the naming, the proper naming of the file being done. Once it is done, the file component of our app would append that value to the desired folder. That would take the global name value, and then add a top layer. Like if we are visualizing it in a computer or something, that should be timestamps and values. That after that, the recordings or the text values which has been captured throughout 20 seconds would be recorded here. Added to the text, and that entire text will be saved as a name, under a folder called recordings, which is under the scope of the app. Like this app would be only the one which can access the data. Okay, this won't be accessed by the entire mobile app, but we can use PC to capture the signals or to capture the saved files. Okay, this is what it does. The CSV file, once it is saved into the recording, and it stores that thing. Then we will be clearing all these values. Record count, it will be set into 0. The counter 20, that countdown thing would be also set to 20. Global record data will be empty. Now we set it for the next capturing. Then will enable the button, the save button, and wait for the other person to trigger it. Label will be then set to, like as I told, the counter was going on, it has to be set able to record for 20 seconds. That is step. Once the successfully these things are being done, will pop up a message that your file has been saved successfully and the name of the file will be displayed over here. So this is what the entire app does in the plotting and recording section. Okay, this is the logic behind that, or the code blocks behind that. I'll share the entire code in the description. You can use it also. Next, we'll move on to the main thing where we will be showing how the recorded data is being shown. As I have shown the recorded thing, how we'll do it in the UI perspective, I'll show the code blocks. So, as I told, we have a list picker where we select the CSV file that has to be shown here. So basically, what it does is the list picker goes to the file, asks that file scope, like basically where it has to find where the file component has to search for those data. It goes to the scope of the app, then goes to a file or a directory name recording. So over there, it will find a lot of folders. It will then record it all. So record it all, so list out all the recorded CSV files. And then once we click any of these files, then that file would be redirected, and then the file name. The file would start reading that file. Okay, it's reading the name. So it shows that in the recording file, what we have is the list picker. What we have selected. So it will be basically recording / the name of the file which has been selected. Once that is done, it will then prompt you to the second thing, like where the loading of the, as I told, everything goes done in a text format. Okay, the CSV file we have loaded, that CSV file is then converted into a text file basically. That is initializing and reset that text or the CSV file which is unloaded to the variable. It stores the CSV list basically stores the CSV file content. Once the content is ready or the text is ready, that the block shows that when file 1 got text, when the text has been given to the file, what it does is basically removes the first element. As we are plotting, we don't need the first element or the time or value thing which we added in the first row of the CSV file, that is removed. Then the buttons, two buttons will be enabled. That is the share button and the display button. Okay, display or plot button. String will be enabled. And as of now, we have the converted one, the CSV to text converted data we have, and then using these two buttons, we can either share it or we can give it to the plot to plot it. So we have here we have two buttons. Here, call chart data to, like this is a two-dimensional chart, so it will call it and clear. If there is a previous element to that, it will clear it out. Then the data from the list which has been text list which has been selected on the first option will be then inputted to the chart, and it will display it. Okay, it will display it like this. Okay, so that is done by the button 1 or the load the file button. Then comes the share button where we have a sharing element which will basically capture the file location. Once the file location has been captured, it can share it using all these components. It can share over Bluetooth, or it can share it to the Drive, Gmail, or WhatsApp also. So these are the basic features of the app. And thanks a lot for your patience for hearing. I've added all those required files into the description. I hope you like the video.